Hello students and welcome to the third module. In this module we are going to talk about electronics components, laws and theorems that will regulate and control the use of these components and help you in making a good project. The first one that we have is Ohm's law. As you would have studied, Ohm's law states that the voltage across a resistor is directly proportional to the current flowing in this. It is not the other way around. You should not say that the current flowing in a resistor is directly proportional to the voltage applied. Okay, so that is one confusion which you should not have. V is proportional to I and the proportionality constant is the resistor R. So we write the equation as V is equal to IR. This is our first equation. After that you can modify this or rewrite it like I is equal to V by R or R is equal to V by I. So now we need to know about some of the circuit elements that are commonly used and very helpful in circuit analysis. Two of them are open and short circuit. A short circuit is the one which is having almost zero resistance between the two terminals. So what is the meaning that if I have two terminals, I call them A and B, then the effective resistance between them is almost zero. A finite or infinite current can flow and the voltage, which is I into R, since R is 0, that means voltage will be 0. So there are two things which are definite about a short circuit. The first one, resistance is 0, almost 0, and voltage is also 0, but the current cannot be defined by the short circuit alone. The current will depend on the other circuit elements which are there inside this black box, which we are not showing in this block diagram. Similarly, we have open circuit where the resistance is almost infinity. Open circuit can also be called as a broken circuit or incomplete circuit. The resistance between these two terminals is infinity, that means the current is not flowing, but that does not mean that the voltage across an open circuit is zero. Voltage cannot be defined by these two parameters here. The voltage at point A and B can be calculated by other circuit elements, and the relative voltage between A and B will be the difference between voltage A and voltage B. So two definite things are resistance is infinity and current is zero. Nothing can be said about voltage by looking at the open circuit alone. These concepts should be very clear in your mind. So, very simple example. I have a 30 volt source, 5 kilo ohm resistor. What is the voltage across this 5 kilo ohm? In this circuit, I have only one active source and one passive source. What is active source? Active source are those which generate power. Passive sources are the ones which only consume power. So whatever is being produced, the same will be consumed. So if I am generating 30 volt, this resistance is going to have 30 volt. So voltage is 30 volt, that is clear. How about the current? So we'll use the relation that current I is equal to V by R. Voltage across this resistance is 30. 30 divided by 5. I get my current value as 6 milliampere. So that was easy. And where do we use these? So you can remember we were calculating the current across an LED. So this is the concept we are going to use. What are the other places where we are going to use Ohm's law in our training? We are going to find that what are the minimum and maximum operating values for every component using Ohm's law. When you take a component, it comes with a data sheet that will mention that what are the minimum operating conditions and maximum operating conditions. Minimum conditions are also required as well as maximum conditions should be avoided. Consider one example, you want to glow an LED. If you do not provide sufficient voltage or current, the LED will not glow. If you do not provide sufficient current to a DC motor, it will not start rotating. Similarly, if you provide anything more than the maximum, your components can burn. Your sensors, your displays, your motors or LEDs, they can burn if you provide voltage or current more than the specified limit. And how do you know these limits? Ohm's law. That is going to help you. So now we are going to go and test these principles using a very simple circuit on Tinkercad. So we have a simple circuit. I have a 9-volt battery connected with 4 LEDs. All these are green LEDs. Cathode of each LED, this terminal is cathode, the black one, is connected to the ground, and anode of each LED is connected to 9 volt. All of them are forward biased. So your prediction that what should happen if I press the start simulation button? All the LEDs are forward biased. All of them should glow, right? They are provided with more than 2 volt. We are giving them 9 volt, so definitely they should be glowing fine. So I do that and I see, well, they are glowing but in a different way. The rightmost one says the current through LED is 900 milliampere while the maximum allowed is 20. Okay, that means this LED is gone. This has burnt. The second LED is showing a warning signal. That means the current is very close or slightly above the maximum threshold. The third one is working fine. The fourth one is glowing but very low. So what are the reasons for that? The only difference these 4 LEDs have is the value of series resistance in their forward biased path. The first LED do not have any resistance, so the current is not limited, it is very high. The second LED is having a resistance of 200 ohm, the third one is 1 kilo ohm, and the fourth one is having 10 kilo ohm. As you increase the resistance, the current is reducing. The current should be set in the optimal range. It should not be below the minimum, which is here in this case, and it should not be above the maximum, which is these two cases. So you should avoid these cases and choose an optimal value, and Ohm's law is going to help you. So we talked about choosing a correct value of resistor. We have capacitors also, so we are going to work on resistors and capacitors in the next video. Thank you.